us as developers, of course, we work on producing our Java code. Okay, so, and remember, star just means it's a pattern matching. It just means anything that ends in .java. Okay, so this is what we end up doing, at least to begin with. And we make, as our programs get more complicated, we will make many Java files. Okay, and for you right now, this of course is this stage of development. Okay, you make your code first of all. And how you do this is kind of up to you. We've sort of recommended that you find some editor you like, and that can be a simple text editor. It can be a slightly smarter text editor like VS Code or Atom, or it can be a fully blown IDE, such as kind of how do you write IntelliJ? It's a strange one to write. Okay, you'll use some kind of tool to develop these. Okay, well, once you have all your source code, then you will move on to the next stage, which is to compile. Now, at this point in time, we need a tool to help us. Okay, we can't manually compile our tools. So if you've been doing stuff on the command line, you will have used javac. Okay, and you can type something like javac star.java, and it will go away and compile all your Java files. If you use something like IntelliJ, it might be building the thing for you all the time in the background to make your life a little bit easier. Now, if things don't go well, typically what happens is we have to go back because we have some type of syntax error. Okay, so the compiler is very good at spotting problems. For example, you misnamed something, you forgot a semicolon, or you had incompatible types, or all sorts of different things. Okay, but if it works, it should produce some, again, I'll just use a star, class files. Okay, and you'll see these appearing in your terminal, or if you're using IntelliJ, you might have is it a binary folder? I can't remember. Okay, but you basically have these executable bytecode. And if you weren't here last week, we tried looking inside one of these files in the text editor, and we didn't really get that much. Needless to say, we don't really need to worry too much about what's in here, but once we get these, we can understand this to mean, okay, we have something we can actually now execute. Okay, so that will be our next stage. When we actually try to execute our code. Now, you would hope if everything compiled, there would be no more problems, but I can still remember to this day my old algorithms and data structures teacher saying that he gets worried when it actually does compile, because that means the bug that's actually happened. So if this actually blows up and, you know, does not work as expected, that was meant to be boom, but didn't really work, you have a much more subtle bug. These are the kind of the easy things to fix. Usually the compiler will say something went wrong in this particular line. The message might not be super helpful, like symbol not found, but you soon learn what those mean and you know how to fix it. We have these runtime errors. These are much harder to diagnose because typically they might be of logical nature. For example, your compound, really impressive if-else statement just didn't make sense and gave you the wrong outcome. Okay, but maybe that didn't happen. And of course, what we kind of hope is that we actually get a program that ultimately completes whatever it was doing. Okay, and if we get to that, then of course we are actually quite happy. I'm pretty sure if you've only started programming over the last couple of weeks, you've probably spent a lot of time around about here working on the writing code and compiling code and then getting syntax errors and then just going through this loop over and over again. And sometimes it feels like the actual program working the way it expects to is a very far goal. But like I said, if you get these logical errors, then they are the ones that are usually much harder to solve. Okay, so again, we can compare how close